Hello friends, welcome to Technical Lab. This is Rohit Sharma and this is a network theory formula revision number 4 and is the last part, okay? Last part for network theory for ISRO technical assistant exam. Only this much part is coming in your exam for network theory. Okay, now what I am including in this video is first is introduction to resonance, series resonance, features of series resonance circuit, parallel resonance and the features of parallel resonance circuits. Okay, so let's start the video. First, what is resonance? Resonance is a condition when the voltage across the circuit become in phase with the current supplied to the circuit. That is, voltage is in same phase with the current applied. Okay, like this. That means they are saying phase angle is 0, and for resonance cos phi, that is the power factor should be at unity. Power factor should be unity for at resonance condition. Now if I am talking about series resonance, then the voltage across inductor should be equal to the voltage across capacitor, okay, for a series resonance circuit. Okay, also I can say the total voltage across resistor VR should be equal to V for a series resonance circuit. Okay, at resonance the circuit behave like a purely resistive circuit. No inductor and capacitor should be there. Third, power factor of the circuit at resonance is unity. Okay, now we will talk about what is series resonance. Now series resonance, this is a series resonance circuit. To check resonance condition, at resonance VL should be equal to VC, that is the inductive voltage should be equal to capacitive voltage, and these are 180 degree out of phase. Okay, imaginary part of input impedance should be 0, that is Z input at omega equal to omega naught should be R, so that it can give minimum resistance. Okay, if there is minimum resistance, then the current will be maximum. As we know that current is inversely proportional to resistance. If resistance is minimum, then the current will be maximum. Remember this. Okay, and the current at omega equal to omega naught will be equal to Vs upon R, that is maximum current, that I have already told you here. Now omega naught is the resonant frequency. Omega naught is the resonant frequency which is given by 1 upon root LC radian per second. If you want to find the frequency, resonant frequency in hertz, then it will be equal to 1 upon 2 pi root LC, as we know that omega is equal to 2 pi f. Remember. Okay, this is omega naught, this is the omega 1 and omega 2, that is the half power frequency. At omega 1, the current, at omega 1 and omega 2, the current value will be I naught by root 2, that is 0.707 times of I naught. Okay. So please remember these points for a series resonance circuit. For a series resonance circuit, they are saying if omega is less than omega naught, then the series RLC circuit will behave like a RC circuit. Okay, if omega is greater than omega naught, then the series RLC circuit will behave like an RL circuit. And at omega equal to omega naught, it will behave like a purely resistive circuit. That is, at here the power factor will be unity. When it is an RL circuit, then power factor will be lagging in nature, and when it is an RC circuit, then it will be leading in nature. Remember this point. Okay, can be asked in MCQ point of view. Okay, now what is the value of bandwidth? What is bandwidth? The bandwidth of the network represents the range of frequencies at which the current drawn by the network becomes 0.70 of its maximum value. So bandwidth is given by the difference of omega 2 minus omega 1, that is the half power frequency, where the current is 0.707 times of I naught, that is 1 by root 2 times of I naught, okay, of its maximum value. So bandwidth formula can be given as R by L for a series resonance circuit. Okay, and omega naught is also equal to root of omega 1 into omega 2. This is also the formula. Omega 1 and omega 2 are the cutoff frequency, or you can say the half power frequency. Now what do you mean by quality factor? Quality factor is equal to the ratio of maximum energy stored upon the energy dissipated per cycle. Okay, remember this. So quality factor is equal to 2 pi into maximum energy stored upon energy dissipated per cycle. Remember this. This is defined by quality factor. Now quality factor of the network is a measure of the sharpness of the curve for the current. Remember, can be asked in MCQ. Quality factor is the measure of sharpness of the curve for the current. Okay. So frequency at quality factor, the formula for quality factor is equal to omega L by R for series resonant circuit, 1 upon omega RC for parallel resonant circuits, and for series it is equal to 1 upon root L by 1 upon R root L by C, and for parallel it will be equal to R root C by L. I will tell you in the next slide. Frequency at which voltage across capacitor is maximum, it is equal to Fc is equal to 1 by 2 pi root of 1 by Lc minus R square upon 2L square. Frequency at which the voltage across inductor is maximum, this will be equal to 1 upon 2 pi root of Lc minus C square R square upon 2. Now selectivity is known as, selectivity is equal to resonant frequency, that is F0 upon bandwidth, which is given by F2 minus F1. This is known as selectivity, the formula for selectivity. Now what are the features of resonant circuit? This you can study from here, okay, read out from here, or you can make out notes from here. First of all, the resonant frequency is geometric mean of 2 half power. I have already told you omega naught is equal to omega root of omega 1 and omega 2, can also be written like this. Okay. Now, resonant frequency represents the rate at which electrical energy stored in the capacitor is transformed to the magnetic energy stored in the inductor. That means they are saying that resonant frequencies represent the rate at which electrical energy which is stored in the capacitor is transferred to the magnetic energy stored in the inductor, or you can say vice versa. Okay. The quality factor represents the voltage amplification factor. For this voltage amplification factor, you can see my resonance video on my YouTube channel. It should have a high value for a series resonance circuit. Okay. Quality factor can be calculated, numerically calculated by RFC component, that is 1 upon R root L by C for a series resonance circuit, and R root C by L for a parallel resonance circuit. Okay. For tuned network, the quality factor must be high, the bandwidth should be small, and therefore the resistance used in the network should be small. Please remember these important points. Okay, I am marking them as star. Okay, any series RLC network represent as a band pass filter. Remember this point, very, very important. Okay, now next is a parallel resonance circuit. This is the graph for parallel resonance circuit. Here I is divided between, I can be written as I equal to IR plus IL plus IC, like this. Okay, at resonance IL is equal to IC, and these are 180 out of phase. Here the resistance is maximum for a parallel resonance circuit, but the current will be minimum. Why? Because current is inversely proportional to resistance. If resistance is maximum, then current will be minimum for a parallel resonance circuit. Omega naught value will remain same. Omega naught is equal to 1 upon root LC for both series resonance as well as for parallel resonance. Now remember this, at omega naught it will be an RL circuit. For series resonance it was an RC circuit. Okay, now this will be in lagging nature. At omega greater than omega naught, the circuit behaves like an RC circuit. Okay, so this will be leading in nature. And at omega equal to omega naught, this will be a purely resistive circuit, then power factor will be unity here, like this. Now next, bandwidth. Here bandwidth is given as 1 upon RC for a parallel resonance circuit, and for series it was R by L. Okay. Now quality factor for a parallel resonance circuit is given as omega naught RC, R upon omega naught L is equal to R root C upon L. Okay. For series resonance, I have already told you there, but there was one mistake I have taken. First is, for series resonance it was 1 upon omega naught RC, also omega naught L by R, also 1 upon R root L by C. This is for series resonance, and all three formulas are for series, and these all three formulas are for parallel resonance. So please remember this. There was one mistake at the last, if you see the video again. So these are the three formulas for series resonance circuit for calculating quality factor, and these are the three formulas for parallel resonance for calculating quality factor. Okay. Now last, what are the features? The quality factor of the network represents the current amplification factor, and for series resonance it represents the voltage amplification factor. Here it should have a high value. For a tuned network, the quality factor should be high here. They should have low bandwidth, and their capacitance value should be kept high. Remember, a parallel RLC circuit will behave like a band stop filter, or you can say a band reject filter. So I can say a parallel RLC circuit will behave as a BSF or BRF. Okay, for series it will behave as a band pass filter, that is BPF. Okay, so these are some formulas or concepts based upon the resonance, series resonance circuit and parallel resonance circuit, and here the formula series for network theory is completed. Okay, for the syllabus which is coming in, your ISRO technical assistant exam for electronics. Okay, now if I will complete the formula series for NCL exam, that is for Northern Coalfields Limited. Okay, then whenever the syllabus will uploaded on the website, and according to the syllabus I will add up the formula series for network theory. Okay, after this, from today's video, after when we have completed this network theory, after this video we will complete our basic electronics formulas related to the ISRO technical assistant exam. So okay guys, all the very best, take care, and we will meet in our next formula series number 5 for basic electronics. Okay, bye.